All right, this video is to go through the momentum practice problems that you copied into your journal, and just to make sure that you are clear on how to plug in all of your numbers and how to work problems using momentum and impulse. So question number 1 talks about the momentum of a football player. The question says, what is the momentum of a 62.9 kilogram football player running forward at 3.40 meters per second? So we know that our equation for momentum is P equals mv, or momentum is equal to mass times velocity. This is a really simple one. We can just plug in what we know. Momentum is equal to 62.9 kilograms times 3.40 meters per second. Just multiply those two numbers together and you get the momentum of this football player is 214 kilogram meters per second. We just squish those units together for momentum. Question number 2 is looking at the change in a race car's momentum. So the question says a 700 kilogram race car slowed from 30.0 meters per second to 15.0 meters per second. What was its change in momentum? So we're looking at delta P, or change in momentum, is equal to m times delta V, mass times the change in velocity. And remember, this delta, which means change, is final minus initial. So what did you end at minus what did you start at? So our delta P, our change in momentum, is going to be equal to 700 kilograms times 15 meters per second minus 30 meters per second. We put the 15 first because that's what we're ending at. The race car is slowing down. So our VF, our final velocity, is 15 meters per second minus our initial of 30. So we get 700 kilograms times negative 15 meters per second. Now we can just multiply those two numbers together. And the change in a race car's momentum is negative 10,500 kilogram meters per second. This is another vector quantity that can be negative. Okay, if it's slowing down, it's going to be negative. If it's speeding up, it'll be positive. Number 3, we're looking at a little bit of proportionality. So it says a bicycle has a momentum of 12 kilogram meters per second. What momentum would the bicycle have if it had twice the mass and the same speed, is what we're going to start with. So we know that our momentum is 12 kilogram meters per second. Okay, that's our P, and we know that that's equal to some mass times some velocity. Well, what happens if we double our mass? Okay, we're doing a 2 times m on one side of the equation, which means we have to do a 2 times p on the other side of the equation. So if we double the mass, we double the momentum, which in this case makes it 24 kilogram meters per second. Remember, anything you do on one side of the equal sign, you have to do the exact same thing on the other side of the equal sign. Part B of this question says, what if it had the same mass but half the speed? Okay, so we've got our momentum, 12 kilogram meters per second, equals some mass times half of a velocity. So if we multiply by half over here, we have to multiply by half over here. So half of P, or half of 12 kilogram meters per second, is going to equal 6 kilogram meters per second. So if we double our mass, we double our momentum. If we cut our velocity in half, we cut our momentum in half. It's that simple. And question number 4 is talking about the impulse on the car. So the very first part of the question says a 2,200 kilogram vehicle traveling at 26.0 meters per second can be stopped in 21.0 seconds by gently applying the brakes, in 3.8 seconds if the driver slams on the brakes, or in 0.220 seconds if it hits a concrete wall. The first part of the question says, what is the total impulse exerted on the vehicle? So if you look in your notes, you've got two ways to find impulse. So impulse can either be force times time, but it's also equal to our change in momentum. So impulse is equal to mass times our change in velocity, our delta V. So let's look at what we have. Impulse is equal to the mass of our vehicle, 2,200 kilograms, times our change in velocity. Our final velocity is 0 meters per second because the car is stopping. Our initial velocity is 26 meters per second. Notice that time has no bearing on our answer here. We're just looking for the impulse. What's our change in momentum? So 2,200 kilograms times negative 26 meters per second gives us an impulse or a change in momentum of negative 57,200 kilogram meters per second. Well, now what can we do with that? Let's look at the second part of the question. The second part says, what is the average force exerted on the vehicle in each of the three stopping methods? Which means we're going to have three answers here. Our impulse is the same no matter if we stop slowly or quickly. So the impulse is always negative 57,200 kilogram meters per second. I want to know how much force I'm putting on my car by stopping it in a certain amount of time. So gently applying the brakes is our first one. And if we look at our equation, impulse is equal to force times time. When you rearrange that to solve for force, it's going to be equal to impulse divided by time. So in this instance, we're going to say that our force is equal to negative 57,200 kilogram meters per second divided by our 21 seconds that it takes to stop when gently applying the brakes. When you plug this in your calculator, you get negative 2724. 2,724 newtons of force in the negative direction is being exerted on the vehicle in this case. Well, what if we slam on the brakes? Okay, if you've ever been in a car where you've slammed on the brakes, you know that you feel that a little bit more. You jerk forward a little bit more, and you can hurt yourself if you jerk forward too quickly. So what that means is that there's going to be a little bit more force exerted on that vehicle. So again, rearrange our equation. Force is equal to impulse divided by time. So negative 57,200 kilogram meters per second divided by 3.8 seconds, in this case, is equal to negative 15,053 newtons. So quite a bit more force is being exerted on the vehicle by stopping quickly. And the final question, what happens when you hit a concrete wall? How much force is exerted on the car when you hit a concrete wall? So in this case, force, negative 57,200 kilogram meters per second, divided by that very short time, 0.220 seconds, is going to be negative 260,000 newtons of force exerted on the vehicle when you slam it into a concrete wall. It's quite a bit of force. Go back over the questions and make sure that you've written out all of the work and the answers. Make sure that your numbers all have units on them. Remember, always show your units. And then you're going to take a picture and upload to get your credit for today.